Hi everyone, since we are done discussing in chapter 2 the motion in a straight line, and we have also discussed the free fall, so we're going to proceed with motions in 2 or 3 dimensions. So our learning goals for this chapter is to represent the position of a body in a 2 or 3 dimensions using vectors. Also, we're going to determine the vector velocity of a body from a knowledge of its path, and also to find the vector acceleration of a body and why a body can have an acceleration even its speed is constant. So, what determines where a baseball lands? And how do we describe the motion sa kanang roller coaster nga moagi along the curved track? So, which is kani siya nga mga question dili ni siya matubag sa katong chapter 2 nato kay straight line raman to siya. So, in this chapter we will learn kung daghan na og dimension siya. So, kaning roller coaster na anay curve. So, dili na siya straight line. So, let's first discuss the position and vector velocity. So, to describe the motion of a particle in space, we must first be able to describe the particle position. So, let's consider this. So, kay 3D naman ninyo. Drawing taog. 3D pod. So, let's say this is your x-axis, the y, and the z-axis. So, you have here point P, or this one. This is point P. This is position P of a particle at a given time that has coordinates of x, y, and z. So, we must find the position vector R. So, position vector na siya pag vector, ang sagani ang vector na magnitude and velocity. Let's say R. So, na siya inana sa babaw. So, kung magnitude lang, scalar quantity na siya. Okay, let's proceed. So, R is expression na sa x I hat plus y j hat plus z k hat. So, muna na si position vector. Okay, let's say this is dali sa babaw. Dali sa babaw si P. Kung nasa babaw si P, ang saman pag-add to ni Madira. So, kung kanina siya, imuhang origin. So, 0, kung diri origin, kung 3 na siya ka-point, kakuan. So, may siya, 0, 0, 0. Muna ang origin pag 3D na siya, 3 dimensions. So, from the origin, padulong ka sa x, derivative, pasaka ka, padulong dagto kang y, then some distance, padulong diri nga z. Then, kani, connect nimo ang head ug ang tail sa imong vector. So, muna si Pino. Mauna dahil ni si position vector R. Panidari from tail sa imong x. Padulong sa z. Kani si z. And kani si y. Muna dahil na siya. Mong position vector nimo. Okay. So, what if there's a change in your position? So, or the displacement. Saan naman na? So, na ay change. Kung kani siya, si P, may man na siyang P1. So, mo. Sana. Wala na pagtaglain. Z, Y. X, P1. So, let's say ni move siya dari. So, muna mong position at time 1. So, muna niyang path. Tanita mo ni path sa mong particle. So, may particle. Then, tanita ang mga path niya. And, this is your at time 2 or dira ay mohang particle 2. So, from the origin, mo ni si pagani ha si R1 displacement ni mo and diri si mohang R2. So, kani nga line between them is your delta R. So, which represent the displacement vector. So, displacement vector, saan na siya? So, delta R equals sa R2 minus R1. So, kung represent mo siya ginani, XYZ, so, X2 minus X1 times I hat, and then, plus Y2 minus Y1 J hat, plus Z2 minus Z1 K hat. So, pag nakay-change, muna na imuhang change ha, imuhang displacement. So, we can also define another quantity which is the average velocity like the previous example sa itong niagin. Kuan lang to. Naka 2D lang to itong system. So, ang velocity, change gihapon siya sa imong displacement over sa time. But, in this case, 3D lang na siya. So, velocity. So, we have R2 minus R1 divided by, so, T2. So, the time it takes for a particle to reach at this point or position. And your T1 is the time it takes or the initial niya position niya. So, T2 minus T1. So, this one here is your change in position or displacement over the change in time. So, saan na siya quantity? This is the average velocity vector. So, average velocity vector. Sa padjud ang quantity. So, same ratong niagi. Naagi hapon ni siya instantaneous velocity like we did in the chapter 2. So, V. Average, ayahang instantaneous. So, the limit of delta R over delta T as your time approaches to 0. So, paano mo ito mo? Derivative siya sa imuhang displacement over time. So, the magnitude of your vector V at any instant is the speed of your particle at that instant. Okay, what else? Okay. So, the components of instantaneous velocity. So, Vx. So, tulog hapon ang components sa kani kay 3D man. So, Vx, you can get that one. Derivatives mo, ha? X over time and dvy, dy over dt, and dz. So, dz over dt. And, ang sanan, pagpangita sa magnitude, ani. So, same ra gihapon. So, magnitude. So, kanino? So, equal siya sa, kung magnitude na scalar na siya. So, pareha na. Vx squared plus Vy squared plus Vz squared. Okay, let's have an example. Kindly refer to your book na kung gihata example 3.1. So, I'm going to show it to you. So, a robotic vehicle or rover is exploring the surface of Mars. The stationary Mars lander is the origin of coordinates, and the rounding Martian surface lies in the xy plane. The rover, which we represent as a point, has x and y coordinates with time. So, x and y lalagyan nila. So, x is given by 2 meters minus, so function ang nakagiven 0.25 meters per second squared, and the y also, which is 1 meters per second times t plus 0.025 meters per second cube times time t cube. So, find the reverse coordinates and distance from the lander at time equal to 0. So, 2D ra. So, how are we gonna solve this one? So, wala siya z. So, first, we have to get the given. So, to x 2 minus 0.25 t squared. So, a function of time. So, y is 1 times t, or t na lang na siya, plus 0.025 t cube. Lagi pang wala na nato na akong mga units. Pero same thing ra na sila. So, ang ipangita nimo ang rover coordinate ang iyahang distance sa lander. So, ang rover muna ang katong mudagan. Ito, murag robot niya. Robotic vehicle or rover muna siya. So, pangitaon nimo ang iyahang coordinates at 2 seconds daw. So, given naman ta og saan. So, at time equal to 2. So, kani 2 seconds, substitute rin na ni mo dara sa t. So, your x coordinates, so 2 minus 0.25, and then 2 squared. Squared man na. So, 1, so, na kay pila? 1 times ay 4 times 1. Okay, nakay 1 meter. And then, for y. So, if you're wondering here, nganong meter nang yung unit, di ba? Atong given kaganiha. Kani, si 2. Ito na na siya, x 2 meters daw. 2, aning mga m, unit na siya, 0.25 meters per second squared. And then, t squared. So, pag substitute na 2 seconds, so kanina meter yung unit 2 minus 0.25 meters per second squared, and then 2 seconds, and then squared. So, makancel ang unit nga second squared. So, nimo ka, kanipila 2 minus 0.25, 2 squared is 4. So, 4 times 0.25 is 1. So, 2 minus 1 mo nang nakay 1 meter. So, for y, ito naman si y. So, y is equal to, so, 1 daw siya, meter per second. And then, times t man ito ganihan. Plus 0.025 meter per seconds cube times t cube. So, substitute gyapon nimo ang 2 seconds. So, 1 meter per second times 2 kay 2 0.025 meter per second cube. So, 2 seconds cube. So, cancel ang seconds cube. 2 seconds. Kanito, walang seconds. So, 2 meters plus 0.025 and then 2 cube. Pila man na si 2 cube. 2 meters. Plus 0.025. 2 cube is 8. 8. Pila man ni 2 cube. So, nakay 2. 0. Or 0.2 ni siya. 8 times 0.025. So, 0.2 and then plus 2. You have 2.2 meters. Na kay x and y. So, the rover distance from the origin, so, is given by, so, duha raman na siya gyapon, gihatag ang magnitude. So, r is square root of x squared plus y squared. So, 1 plus 2.2 squared. You have 2.4 meters. Coordinate lang na. And, kung ang displacement na, so, coordinate rin niya. Kung displacement na, kung ang gipangita in terms of position vector na dayon. Saan man eh. So, find the displacement and average velocity over the given time interval. So, our time interval, so, gikan sa 0, sa position vector, gikan sa initial niya, or ihang, kaning initial niya is 0 man. So, pangitao na to ang position vector. So, for B, yung tao na to ni si delta R. If gikan siya sa iyahang position vector at time equal to 0 padulong sa 2 seconds. So, how are we going to do that? So, delta R, stick to the same process. R2 Ito man. Minus R0. Kani-indicate lang na to ang time. Okay. So, but ato sang i-express mo si R. So, R, X, I, plus YJ. So, this is the general name. Kung duha ra ni sila man. So, dili na ta maabot sa Z. So, if tulo, apilo na to si Z. So, katong kuha na to kaganing function. So, 2 meters minus 0.25 meters per second squared t squared times mo ni si x, so times lang nato og I hat, and then plus katong y nimo nga function 1t so to plus 0.025 meters per seconds cube times t cube and j hat. So at t equal to 0 or 0 seconds nimo, imong position vector at 0. Kung t 0, so kani ma-0. So mabilan kag 2i. No ma-0 ni kay nakatapad siya og t. And t is 0 man. So wala na siya. So 2i, and then na pa ba? Na j wala. So walay j kanina ay t. Na ay t niya 0 man si t, so walay j. So, pwede ra ka magbutag plus 0j or wala lang dyan. Ibutang nga j. So, next is at time equal to 2 seconds. So, your position vector nakay. So, 2 katura ganin na ang answer na to. Butangan lang ni nato o. So, katong natay 1 and 2.2. So, aha to si 1 sa x, di ba? So, nasa sa x. So, nakay x nga 1. So, I. And then, dari, nakay 2.2 plus, ano man na si y, 2.2 j hat. So, nanatay values for the position vector R2. So, makakuha na tag displacement delta R. So, R2 minus R0 nimo. So, I hat plus 2.2 j hat. So, this is the R2 minus R0 is 2i. So, evaluate. So, saan siya pag-evaluate? Itong na pareha o isa man ni sila. Unit kaning directions. Like, si I, sa I. So, kani. So, 1 minus 2. 1 minus 2i hat. And then, plus 2.2 j hat. So, 1 minus 2 is negative 1. So, you have negative I hat plus 2.2 j hat and then meters. So, muna dahil ni imong position vector. So, if you're going to find the velocity, so makuha ra po na nato dahil. velocity na pod. Na naman tayo values no? Average velocity. So, delta R over delta T. So, delta R, nana tayo delta R, this one. And delta T is 2 minus 0. So, 2 ra. So, delta R na to is negative I plus 2.2J. So, divided by 2 minus 0 seconds. So, na siyang negative I plus 2.2J divided by 2. Okay? So, negative so, makanin nga expression, marakag negative I over 2 plus 2.2J hat over 2. So, negative 1 over 2. So, negative 0.5. 2.2 divided by 2, you have plus 1.1 J hat. And the unit is meters per second. Okay? If you have clarification, pwede rin mag-chat sa ito ang GC. So, we can also get values for the instantaneous velocity. So, what we have here, so, naka Vx, dx over dt. So, kaganiha, natay given nga time 2 minus 0.25 t squared. So, kana imuhang kuan o derivative 2 minus 0.25 t squared over dt. So, mag-differentiate taan yun. Sa ganito kung diingon last meeting. Derivative of any constant is 0. So, kani si 2, derivative ana 0. So, kani constant nakatapad og variable, so you have to apply power rule. So, copy si constant 1 minus 0.25 and then bring down nimo ng exponent diri, copy nimo dira 2 and then t 2 minus 1. So, always na mag minus 1 sa iyahang exponent. So, 2 minus 1. So, 0.25 times 2, pila man na siya? Negative ni siya. Negative 0.25. So, nakay 0.5. Pwede rin po natin ako. Okay, negative 0.5 and then t 2 minus 1. So, 1. So, mahimo lang rin siyang t. So, nakay 0.5 t. So, muna mo ha, Vx. Instantaneous velocity nimo along the x. So, for Vy, so dy over dt. So, nakay-function gani ha. For y nga. So, gipangkuha lang na akong unit ha, para di kayo malibog. T plus 0.025 t cube. So, derivative sa t, yun mo siya. So, nasa yung 1 exponent. So, 1, t, 1 minus 1, plus 0.025 copy. And then, 3, copy si 3 dire. Then, t, 3 minus 1. So, 1, t, 1 minus 1 is 0. T raised to 0 is always 1. So, nakakay 1. And then, plus 0.025 times 3. And then, t 3 minus 1 is squared. So, muna din ni mo hang Vy. If you are going to get, isent muna ni ang general niya. Nga ako, function of t. Kung magkuha ka og value niya, instantaneous velocity at 2 seconds, so, kana si 2, i-substitute lang dayon sa mga t. So, 2 seconds, sa v2x, katong 0.5 t, so, mahimo lang dayon ng negative 0.5 times 2. So, pila ni negative 1 meter per second. So, v2y, so, 1 plus 0.025 times 3 and then 2 squared. Evaluate nimo ni na kay 1.3 meters per second. So magnitude ani v2 square root of v2x squared plus v2y squared. So, negative 1 squared plus 1.3 squared. So, naka 1.6 meters per second. So, similar lang din sila sa chapter 2 o concepts. So, muna ang sa position and the velocity vectors. So, next topic would be acceleration na po dayon.